Okay, so we're starting topic 4. Topic 4 has a lot of different things in it. It is not an easy topic. It's advanced mathematics. This is not little kid math. And it's totally worth it. When you end topic 4, if you're working hard, you will know some advanced math. So here we have a graph of an event. This is going to be a graph of the volume of air as a function of time. So of course the amount of air in your lungs goes up and down as you breathe. So we're going to look at a graph of the volume as a function of time. Okay, so as the lungs fill, the graph rises. It actually goes down to zero. I don't think that your lungs actually have a zero volume of air. I think that would end in that wouldn't end well. So that aside, uh, you can probably guess what kind of function we could use to represent, say, this part of the function here. Okay, so we're going to look at a little bit more complicated graph. We're going to look at a graph of the volume in her lungs as she does sit-ups. Okay, so if you thought previously that a quadratic function was going to be a good fit for the last graph, it would have been. Now, this is not symmetric. Each one of these parts of the graph is asymmetric. And the quadratic function, even if you translate it or whatever transformation you do to it, you can't really make it asymmetric unless you add another function to it. Now we're going to be looking for just a pure function that we can adjust to fit some of this data. Okay, so they just tell you right away that a good function might be a cubic function. A cubic function has two of these local maxima or minima at most. It can have zero. And this is a cubic function that also has other components of lower polynomials in it. I mean, it has a quadratic component and a linear component. Okay, so let's look at all the functions we know about and see which one is going to be a good fit. Let's just try to adjust. This is a linear function. Okay, this is your favorite function because you loved algebra 1. Oh, well, what do you know? It's actually a good fit right here. But it fails to represent the function along here. Okay, let's try quadratic. We talked about a quadratic not working. X squared isn't going to work because it's symmetric. And this function is asymmetric. Let's look at the square root function. Square root function, not so great to represent this function. An exponential function. Alright, I'll tell you right away this is not going to work. There's no way for us to change. Oh, okay, well, this fit the backside of the function. Okay, but it's not going to work for the front. Okay, the log function. No, it's not going to work. Okay, and 1 over x. These are all our most important function types. It didn't go over cubic and higher polynomials, but we'll do that. And also rational expressions are really important. So none of these really worked. There wasn't any way we could adjust these. Okay, so here's what you're going to be introduced to right now. Okay, a polynomial. A polynomial is a very important concept. It's not really a concept as much as it is a set of functions. Polynomials can be represented as the sum of higher exponentiation of a variable with different coefficients. Okay, so this says a of n times x to the nth power, and then it decrements downwards. So if n was 4, this would be 3, because 4 minus 1 is 3. So n can be any positive integer. So it actually can be 0, or a of 0. So as long as it's, no, that's not right. It can't be, the value can't be 0. You can have a 0th order polynomial, which is just a straight line. If you had nothing, if these were all gone, and you just had f of x equals a naught, you would just have a straight line. But here we have increasing orders of the degree of the leading term is the most important feature of a polynomial. Okay, so this is a generalized expression for any old function. Okay, we'll elaborate on this in another video.